So now we need to start looking at three-dimensional space. So we're really used to working in what's called R2, the real number plane, where we have the two-dimensional axis. We have one real number line crossed with another real number line, hence R2. And we're really familiar with this, right? Where we have points like the point 1, 5, and horizontal x direction, y direction, things like that. But of course we live in three-dimensional space where we can not only go left, right, forward, backwards, but also up and down. And so we're now going to move into three-dimensional space. Now of course drawing that on the board can be tricky because we got only two directions to work with. Third direction's kind of hard to draw. And so we usually have to use perspective drawing to do that. And the common version that we're going to use for R3 is this, where we're going to put x and y sort of in perspective. You're imagining that you're looking at the corner of the room, where x is pointing this direction, y is pointing this direction, and then z we're going to introduce as the direction that goes up. Okay, so again, this is sort of a perspective drawing. And we can talk about coordinates here, just like we had the order pair 1, 5 there. We can talk about here order triples, because we need 3 coordinates to represent a point. So if I had the point 1, 2, 3, for example, that would mean I need to go 1 in the x direction, 2 in the y direction, and 3 in the z direction. So let's see how that works. So 1 in the x direction would say go this way 1. Now we need to go 2 in the y direction. And in the perspective drawing, that means I'm going to move parallel to the y-axis a distance of 2. So there's 1 in the x direction, 2 in the y direction, and now 3 in the z direction. There's my point, 1, 2, 3. Now you can probably tell that in a planar flat plane board drawing of three-dimensional space, if I just put a dot out here, you can't really tell where it is. We really need something like this to reference where the point is if we're trying to do anything more complicated than that. Now, to help you orient in space the direction of the axes, it's helpful to keep in mind something called the right-hand rule. So the right-hand rule says that if we point our fingers in the direction of the x-axis and curl our fingers towards the y-axis, that our thumb will point in the direction of the z-axis. So in this representation of the three-dimensional space, x here curling towards y is positive z points up. So this is positive x's, positive y's, positive z's going that direction. Notice that if we were going to try to add a third dimension to this plane, that I'd start by pointing at the x, curling towards the y, and the z-axis would be coming out of the board. Positive z-axis would be coming out of the board. Just as an interesting piece of information, computer scientists tend to use the left-hand rule instead of the right-hand rule, and their positive z-axis goes into the board. So if you're familiar with 3D coordinates from computer graphics, be aware that in mathematics we treat things slightly different.